Okay. All right. Welcome, everybody. Anybody who jumps in at any point during this live stream. Hello and welcome. Before I get started today, I'm going to be talking about the anterior cingulate cortex, which is this super interesting brain region. I will show you pictures of where it's at and everything. So I know those neuroanatomical terms can get a little heavy sometimes, but it's a really interesting brain region. We'll get into all that in a minute. But just if you're watching this after the recording, that may be because you are not a member of Sense of Mind's Patreon. You're not a patron. If you are, you get access to these monthly Patreon only live streams, and you also get blog post versions, kind of essay versions of all of the videos, including these live streams. So if you want to check that out, go to patreon.com/sense of mind. The link is in the description of this video. And don't forget to like and subscribe. And to all the patrons, thank you so much for your support. You keep this show going. You are a huge part of that. So thank you. All right. So without further ado, I'm going to jump into this video, which is really about the anterior cingulate cortex. And it really has a lot to do with decision making. So let's get started. All right. So as we all know, the brain is the central orchestrator. It is the control panel of all our actions, our thoughts, and our emotions. Our brains determine the course of our lives because they're the source of all our decision making. And nearly all decisions, or at least many varieties of decisions, involve valuation. And valuation is this process of implicitly calculating the subjective value of the options before us. So, valuation forces us to take various factors into account, even in relatively trivial decisions. So, as an example of a trivial decision, if you're deciding on, tonight which movie or series you'll watch, on your streaming service, you have to think about a lot of things, actually, like how much time you have, whether you want to start a whole series or just watch a movie, which genres you tend to enjoy, which look good based on their trailers, what the reviews say, how much you trust maybe your friend's recent recommendation, and so on. And there's a lot of valuation going on there, determining the value, evaluating these things. But as we all know, that's a trivial decision, right? The most difficult decisions carry more risk. They often force us to take many more factors into account. So, if you're deciding on whether to change your career path, for example, you have to think not only about how much you enjoy one job or one type of job compared to another, but also how much money you can expect to make, how much room for growth there may be, whether you need to move, how much training or education, what resources you'll need, the projected growth of the industry, and on and on. There's all these factors that require you to do this kind of valuation, and just taking all these factors into account. And my point in bringing all this up is that while you probably won't try to evaluate every single factor on, say, a pro-con list or a spreadsheet, some people might, but regardless, something like that is going on inside your head. And that's going to be a lot of what we're talking about in this video with regard to the specific region, the anterior cingulate cortex, which I'll show a picture of in a minute. But the brain's capacity for making value-based decisions is possible thanks to a complex interplay among many brain areas, not just this one. But this ACC, the anterior cingulate cortex, is particularly notable. It has a vital role in calculating the value and uncertainty of potential outcomes, which are essential elements when facing difficult decisions. So in this video, in this live stream, we'll look at the latest research on the ACC and explain how it's involved in decision making. But we will also see that this region, the ACC, is not merely a cold calculating computer module that simply helps us to kind of rationally navigate through the difficult decisions in our lives. kind of intertwined with that, in addition, it also has a deeply important role in emotion, mood, and motivation. And in fact, this is an interesting kind of aside. The ACC, more than any other brain region, has been found to be correlated with overall well being. Other regions are correlated, but like orbital frontal cortex and some others. But the ACC is most consistently found to, whether it's its activity or its structure, seems to correlate with overall well being. So it has this role in mood and emotion and motivation as well. And so at first, these processes may seem like diametric opposites, like rational, logical calculation on the one hand, and then optimal decision making, and then passionate, emotional, and motivational processes on the other, right? But that's really not the case. The emotional and cognitive functions of the ACC complement each other, and it seems that a unifying picture of its overall function is beginning to come into focus, although there's disagreement among different researchers and theorists in this area. But to understand the ACC, we'll first look at where it is and what other brain structures it communicates with, because this will help us see, this will kind of reveal why the ACC is so well positioned to be a nexus of reason and emotion in decision making and behavior. So let's kind of turn to the anatomy and connectivity of the ACC, and I promise this will be brief. Won't linger too much on the terminology, but for this, I do want to show an image of the anterior cingulate, and let me see if I can go ahead and share my screen. Oops. Actually, I'm sorry. I'm not. Don't think I can share my screen. That's my fault. Good thing though that I have this this diagram with me right now. So what you're seeing is the brain in a medial view, and the structure I'm talking about is this, just above this white area kind of in the middle of the brain. That's the corpus callosum right there that connects the two hemispheres. But above it, circling above it, is the cingulate gyrus, the cingulate cortex. And what we're talking about is really this front half of it. So from where my finger is up, this is the anterior cingulate cortex. Anterior just means toward the front as opposed to posterior toward the back. So we're talking about this ACC, the anterior cingulate cortex, from here over. And that just gives you an idea of the territory that we're talking about. And a little bit on terminology to kind of help you wrap your mind around what these terms are. So you saw that it's a strip of tissue lying below the frontal cortex, really. And the ACC is this frontmost region of the cingulate cortex, which I just mentioned. And cingulate comes from a Latin term referring to a girdle, actually, or something that encircles something else. So you saw that it's aptly named because the cingulate cortex encircles the corpus callosum. So it's in this kind of middle of the brain, just below the frontal cortex. It is also part of the cortex, but it is invisible from like the outside of the brain. So it's interconnected. You can kind of see, like, based on its position, it's interconnected with a lot of areas. It's between the cortex and kind of the subcortical regions. And so it has these connections with prefrontal areas, with parietal cortices, with subcortical regions. And the thing is that the anatomical location and the connections between the ACC and other regions of the brain mean that it's really well positioned to integrate behaviorally relevant information across multiple timescales. And now it can become clear what I mean by that in the next section. But the ACC encodes high dimensional information about the value and uncertainty of future outcomes, and it plays a role in decision-making and learning processes. And to understand how that is, I'm just kind of mentioning that because I also want to say the other regions that it's connected to, why this is relevant. So the ACC is connected, it receives inputs from a number of areas involved in emotion and in memory, those like the orbital frontal cortex, the amygdala, and the hippocampus. And it has connections with areas involved in cognitive control, like the dorsolateral prefrontal cortex, as well as motor control areas like the frontal eye fields and premotor areas. So it's really well positioned to be this nexus between the high level sort of analyzers and fine grained processing going on in the neocortex, the cortex above it, and then being kind of this relay or communication or processing center that then integrates information also with these subcortical regions, and then as we'll see, it outputs activity to those as well as the cortex. So this will become clear how this all works, but I wanted to get a kind of a general understanding of where it is, what it's connected to. So I think that should do for the anatomy part. So let's just jump into the function, right? What is this thing doing? Why is it interesting? And we're centering this discussion on decision making and related processes. So I want to bring this back to earth. I want to perform a thought experiment. So say you're a member of a hunter-gatherer tribe. Today, you're in the forest foraging for berries. You know the forest well, you've lived near it your whole life, and so you have a feel for where you might find berries. But you also know that there will be variation in how many berries are on a given bush at a given time, since the number of berries produced by each bush fluctuates from year to year. So, to begin your foraging today, you approach a promising bush. While this one is not often like a big winner, it doesn't always have mountains of berries, it often has at least a handful at this time of year. So as you get closer to it, you're happy to see that it does indeed have some berries. And so you begin picking them off and dropping them into your, animal hide pouch. Soon, however, this bush runs out of berries and you have to decide where to go next. You consider going home, but you quickly dismiss that option because your pouch isn't even half full yet, and your goal is that to fill it up by the end of the day. You think you can probably do that. I promise this will become relevant. I'm just trying to get us thinking about the kinds of decisions that the ACC is really involved in. So upon deciding that you're going to keep foraging, you have to take a moment to think about where to go next. You're considering the different areas of the forest, where the berries tend to grow. And so first you consider heading west, right? It's rich with berries. That area has tons of berries, but you recall that there's a hostile tribe about 10 miles west. So it's pretty risky because they could be in that area. And so you decide against going west. It's just too risky. Next, your mind turns to the time and energy investment you'll have to make to go in any given area of the forest. So you think about if you're to head north, right, you'll have to cross a few creeks, right? And that presents some risk. That's dangerous and difficult, but it'll only take you about an hour to get to the berry patches on the other side of those creeks. So it's an hour investment, but it's fairly risky. On the other hand, if you go south, it will be a smooth and safe walk, nothing you have to traverse, nothing difficult anyway, but it'll take 3 hours to get the berry patches that way. And then the final direction east is, in this example, your home is in the eastward direction, so you're not going to go that way. So what do? You consider all these factors, as well as your current energy level and the warm temperature today, and you decide you're going to go north. You're going to cross those creeks, take that risk, and you just pray that that investment will pay off with at least one full pouch of berries. And you go on your way. So this thought experiment illustrates many, it's incredible like how many of the types of decisions that the ACC, especially the dorsal ACC, is critical for. So we're going to break down the various decisions involved in this example and show how this dorsal ACC is involved. And just to take a quick anatomy break, the dACC, the dorsal ACC on this diagram is really kind of this area in here, maybe going back a little more, but up here before it curls over. So that curve in it right in there is called the genu, which means I think knee or joint. And anyway, it's a bend. And so we're talking about the dorsal that is above the genu. Anyway, not totally necessary to memorize this. I just thought it can help to kind of pinpoint what I'm talking about. So first, we're going to talk about value-based decisions involving considerations of time. So you just, like in this example, you decided to approach the first berry bush, right? That was the first thing you did. You did so because you predicted it would have berries, right? You thought, okay, this one usually has berries. And that prediction was based on your past experience over the years. You noticed it was a fairly reliable bush. And in other words, you calculated that this bush had delivered positive value on average based on your many observations of it over several years. And furthermore, it's close to where you are, so there's not a risk or investment to get there. And so it seems like it would be a good idea. So interestingly, experiments looking at the dACC, the dorsal ACC, have shown that the activity of certain small regions called voxels, which are these 36 cubic millimeter volumes of brain tissue that are measured in fMRI experiments. But the activity of these individual tiny little regions shows that some of these voxels reflect the kind of average value, right? You were saying that there was this value that's averaged over time. This bush usually produces value for you when you're considering various options. So in considering the choice of whether to approach the bush or not, certain voxels in the dACC would increase their activity to reflect that this bush was indeed likely to have berries. So they seem to be doing something, to be calculating this kind of average value. But even in this one decision, the dACC's role goes further. So when you're considering whether to approach that bush, you would also consider more recent timescales. For example, you might think back to when you were foraging for berries last month or last year at that same bush. And while thinking that through, a separate set of voxels in the dACC would represent whether the bush had delivered value on these more recent occasions. So not just the kind of overall average value over time, but more fine grained, like, okay, what about just last month or last year? So let's say that last month there weren't many berries on the bush, but this time last year there were, right? So maybe seasonal variation, or the berries just haven't grown yet because they only grow this month, not last month. And considering these factors, your dACC greatly helps in calculating your final decision. And your final decision being, okay, there's a reasonably high chance that this bush will have berries today, so it's a good idea to head that way. You get there and your prediction was correct. It's not a mountain of berries, but a small handful. So not a bad start to the day. And the dACC was involved in calculating the likelihood that that bush would deliver value based on your observations over time, kind of considerations involving long time scales. But it still doesn't stop there. So after you checked that bush, right, next you have to think about whether you should continue foraging or head back home. And in doing so, you have to check the progress you've made toward your goal. You have to check your progress. So in this case, your goal is to fill your pouch with berries, and you're not even halfway there. And that means you have to keep foraging until you've gotten closer to that goal. To check your progress, you have to seek out a very specific piece of information. That is obviously how many berries are in the pouch. You got to open that pouch, look in, how many? Oh, it's not even half full. Okay, that's the information seeking I'm talking about. Studies in monkeys indicate that the ACC is involved in the decision of whether or not to check how well the monkey is doing on a given task. So, in other words, the activity of a group of neurons within the ACC reflected whether the monkeys would continue working on a task or decide to check how close they were getting to their goal. This population, this individual population of neurons within the ACC, its activity was correlated with what the decision the monkey would make regarding whether it would keep working on the task or decide to check its progress toward its goal. And so that gives us our first indication that the dACC would be involved in this decision of whether to check your progress or just keep foraging or not check it. But more broadly, right, to bring this back to kind of human studies, the ACC is involved in seeking information more generally. So, for example, human neuroimaging studies seem to show that the dACC, this dorsal anterior cingulate cortex, increases its activity when we're uncertain about the outcome of a particular course of action. When we're uncertain about the outcome of a course of action. Depending on just how uncertain we are, we may decide to seek out more information. So the dACC helps us decide when we need to learn more about our situation or environment. Thus, the ACC would be critically involved in your decision to check whether you should keep foraging or head back home. Okay, so there's two things so far that's been involved in these value-based decisions involving time and now checking progress toward a goal. Moving forward in our thought experiment, now that you've determined to continue foraging, your next decision is which direction you should go in. Here you have to make predictions. You have to make predictions about the magnitude and likelihood of reward, such as how many berries you might find, right? Magnitude and likelihood of that reward, as well as the magnitude and likelihood of risk, such as the possibility of running into a hostile tribe or a hungry bear. Okay, so the ACC appears to contain sets of neurons that compute these variables, and they thus aid in the decision of which direction you should travel in. So more specifically, it seems that certain populations of neurons in the ACC increase or decrease their activity in accordance with either the magnitude of a reward, the likelihood of a reward, the magnitude of punishment, or the likelihood of punishment. I'm going to say this in a couple different ways. So there seem to be many neurons dedicated to processing each of those four aspects of value-based decisions separately, all in the dACC. And there are very few neurons that respond to more than one of these aspects. Okay, so in other words, one population of neurons is calculating how many berries you might find. A second population is calculating how likely you are to find berries. A third population of neurons is calculating how bad it would be to run into a hostile tribe or a hungry bear. And a fourth population of neurons is calculating how likely you are to run into that tribe or that bear. And then only a very tiny population of neurons is involved in more than one of these calculations. This is in the dorsal ACC. So there's these separate populations of neurons calculating magnitude of reward, likelihood of reward, magnitude of risk, likelihood of risk or punishment. However, on the other hand, in the frontmost portion of the ACC, so now we're talking about what's referred to sometimes as the rostral ACC, right before that turning over, that right before the genu, right before it curls over. This rostral ACC, rostral means toward the beak of an animal, toward the nose or beak. These individual calculations seem to come together into a final evaluation. So you've got all these separate populations calculating these different aspects of this decision. And then there's this overall evaluation happening in the rostral ACC. And this overall evaluation, you can kind of think of that as your decision, right? The RACC, the rostral ACC, allows us to compute the overall value of very complicated and context-laden choices. So in the foraging scenario, while you're considering all possible directions and deciding that you'll head north and cross the river, the ACC played an essential role in calculating that north was the best overall option. It helped you to consider the value of each direction you could go in and landed on the prediction that north had the highest likelihood of getting a lot of berries relative to the effort required to get there and the potential risks that might await you. It's in the rostral ACC. Now, as a sidebar, a side note, it's important to note that this kind of value calculation, which takes the likelihood and magnitude of both risks and rewards into account, as we'll see later on, this is crucial for motivation. And interestingly, studies have shown that lesions to the ACC sometimes, depending on the particular area we're talking about, result in more or less severe deficits of motivation. So depending on the extent of the damage, can render somebody either less likely to carry out motivated behaviors, that would be the mild cases, or in the more severe cases, feeling as though they completely lack the ability to do anything but kind of lay in bed or whatever's required for survival. And in the most severe cases, it's referred to as akinetic mutism, not moving, not speaking. It's not actually a motor deficit because they can move, they can speak, but they lack this motivational oomph, which seems to be highly dependent on the ACC. So, and from that, in that regard, even your decision to get out of bed and go foraging or whatever you did this morning relied to some degree on the ACC, on this kind of dorsal rostral ACC. So now in our hypothetical foraging scenario, we've kind of reached the end of that thought experiment. You decide to go north. You made that informed decision, that value-based decision calculation. The ACC was critically involved at every stage of your decision-making process, right? But it doesn't stop there, right? We've just summarized the role of the ACC in this kind of decision-making. But now I want to turn to that other thing I mentioned at the beginning: emotion, interoception, autonomic physiology. So let's get into that, because the ACC is not just a cold calculator. It's not just this rational, okay, what's the likelihood of reward, the magnitude of reward, like blah, blah, blah. It's not just doing that. And if it is, it also is involved in these other functions. So let's get into those. So at first glance, like I mentioned earlier, emotion and interoception being the perception of your own body, feelings from the body, whether they're visceral or even some scientists include from the skin down. So feeling on your muscles, your skin, your bones, your visceral organs, all those feelings are interoceptive. That's the sense of the inside or the body, feelings from the body. That's interoception. And emotion and interoception and physiology seem to have little to do with decision making, at least at first glance. But if you take a moment to think about your own experience of making a difficult decision, I think it changes. So let's just kind of go through an example, right? If you've ever decided to change careers, like we mentioned at the beginning, you probably know what it's like to agonize over a decision. And I don't use that word lightly. You might find yourself unable to fall asleep at night because your brain just can't seem to let go of the desire to find a compromise among these competing values and what we were talking about earlier: money, where you need to live, training, education, your own needs, all this stuff. And until you're reasonably certain that you've found a good solution, the process will feel effortful and more or less unpleasant, right? So emotions and feelings are part of the decision-making process, especially in these complex, difficult, risk-laden, context-laden decisions. So it's hard to really separate emotion and feeling from these kinds of decision-making processes. They are different on some level, but they come together, and we'll see how the ACC kind of pulls them together. And furthermore, when you're in the process of deciding, you're putting forth cognitive effort, right? You're focusing, you're using your attention, you're using your powers of kind of rational thinking and emotion regulation, and all these kinds of intensive, cognitively effortful actions. And this tends to increase autonomic arousal. This tends to increase sympathetic nervous system activity, that being kind of the fight or flight response. So whenever you focus on an important cognitive task, your brain marshals resources to keep your brain and body awake and alert, right? And so this is partly the result of increased levels of stress hormones, cortisol, as well as dopamine and norepinephrine. And those are neurotransmitters that are crucial to cognitive engagement, physical activity, waking cognition generally. So that's really important to keep in mind too, that when you're in this process of deciding, there's also this process of stress and engagement and motivation going on. And this helps explain why it's difficult to fall asleep when you can't stop thinking about an important unresolved dilemma, right? Especially one that has a direct impact on your well-being. Because you're trying to go to sleep, but every time you kind of mentally approach this issue of whether to change careers, you get a little flutter in your chest, a little unpleasant feeling in your stomach, a little, or just, okay, I'm awake. Wait, I'm more alert now, because your sympathetic nervous system, right? That sort of fight or flight arm of your nervous system is generating a mild fight or flight reaction, mild stress response that keeps you awake and alert. And that kind of heightened sympathetic nervous system activity can enhance anxiety, right? So from this example, we can see that decision making entails cognitive effort, right? And cognitive effort entails autonomic arousal, that physiological sympathetic nervous system fight or flight arousal, and that can lead to, and often does, modulate emotional experiences. And it is at that nexus, right, between cognitive effort and emotion where the ACC comes into play. So let's return to the anterior cingulate cortex. And this is so interesting because we're going to start to get into what we've been talking about so far are studies that use like brain imaging or recording directly from the brain, and then kind of correlating that with different tasks and behaviors and things like that. And now we're going to not entirely, but largely shift to talking about some of the clinical literature. And if you get into the anterior cingulate cortex at all, what you'll find is that there's almost this divide between like neurologists who study the effects of damage to the ACC on the one hand, or surgeons who might be stimulating the ACC, neurosurgeons might be stimulating the ACC kind of on the clinical side, and then on the other hand, the like neuroscience, brain imaging and recording literature that we were just talking about. And there's this divide. And now we're kind of switching from looking at the neuroimaging to more of the clinical stuff. And we'll see why there's this divide between them. And it comes down to, it seems like the ACC is doing something almost totally different from what the neuroimaging literature would suggest. But we'll see how we can kind of square that circle later on. But let me just jump into this. So according to a 2022 review by Veronica Pelliccia and her colleagues, these are Italian researchers, and they note that since the 1950s, scientists have known that electrically stimulating the rostral, again, that the frontmost portions of the ACC, can change things like blood pressure, pulse, breathing rate, visceral sensations in the stomach, sexual arousal, heart rhythm. These are very autonomic, very physiological effects of stimulating this region. So in other words, the rostral ACC appears to have a direct influence on autonomic arousal. And its influence there then leads to bodily feelings, right? So this kind of coincides with the work of the late neuroanatomist, a guy named Arthur D. Craig, better known as Bud Craig. He is a highly accomplished neuroanatomist, and he wrote that, quote, "The ACC can be regarded as limbic motor cortex in all mammals because of its association with homeostatic, that is autonomic and behavioral, output activity, and its descending projections to the periaqueductal gray in the brainstem." So let me just unpack that. What does he mean by that? So the term limbic, right, he called it limbic motor cortex. Limbic refers to emotions, feelings, and related phenomena. So there's the interoceptive sensations as well as like emotions and those kinds of things. Motor cortex, on the other hand, refers to a region of the cortex devoted to controlling the movements of the body, right? And that's on the actual cortex you can see from the outside of the brain. But he's saying that this area is a limbic motor cortex. So he's arguing that the ACC is a brain area that controls the actions of the body, whether those actions are autonomic physiology, like changing pulse, heart rhythm, breathing rate, stomach sensations, or actual movements of the muscles of the body, actual motor actions. He's saying it controls that as they relate to emotions, interoception, and autonomic phenomena. So it seems to be this nexus between controlling the body and this emotional, interoceptive, and autonomic phenomena. Now, accordingly, in addition to influencing the autonomic state of the body, the physiological state of the body, stimulating the rostral ACC also seems to directly alter people's emotional experience. So, for example, some studies find that stimulating the pregenual ACC, that is the area just above that genu, just above where the ACC curls under the corpus callosum, stimulating that pregenual ACC tends to elicit more positive feelings. It tends to elicit positive feelings, and it can even trigger bursts of laughter, right? So this is triggering an emotional response, an emotional reaction, laughter, right? It's this does seem to kind of be this limbic motor cortex, right? And then another study has found that stimulating the subgenual ACC, that is the region under that curling over of the ACC, sort of under the most anterior part of the corpus callosum, that can elicit feelings of anxiety. But interestingly, one experimental treatment for some cases of treatment-resistant major depressive disorder is deep brain stimulation, direct electrical stimulation of subgenual ACC. So that same area that seemed to elicit feelings of anxiety has this amazing effect on certain patients with very treatment resistant major depressive disorder. And the inventor of this treatment, Dr. Helen Mayberg, has noted that a common thread among patients for whom that type of DBS, the deep brain stimulation, does work, actually helps them get out of their depression quite quickly, is that they tend to describe their depression as something like a deep pit that they've fallen into and can't climb out of. So there's a super interesting book that tackles kind of reviews a lot of this literature on deep brain stimulation for not only for depression but for other conditions, and it's called The Pleasure Shock by Frank. I can't remember her first name, but really wonderful book, really well written, really interesting. The Pleasure Shock. If you want to learn more about deep brain stimulation. But this is just to show that the ACC has this very powerful effect on mood and emotion and motivation. And it can even elicit emotional reactions like laughter. So now at this point, we're still talking about these stimulation studies, but it kind of brings us back to the discussion earlier about goal-directed behaviors, about decision-making, value-based decision-making. And this is super interesting because while stimulating the rostral ACC, like we just talked about, seems to elicit changes in bodily feelings, right, or autonomic arousal or emotional state, Policia and colleagues note that stimulating more posterior regions, right, going back to that dorsal ACC on top, stimulating that area causes bodily movements, but not just any bodily movements. It seems to specifically elicit movements in line with goal-directed behavior. So Policia and colleagues, they describe a study from 1973 that used a particularly high stimulation intensity that was stimulating this dorsal ACC region. And this is so cool. It observed different movements of the hands and lips and the eyes, but the study's authors explained that the particular movement, while it differed from person to person and it depended on whether they're holding anything, one of the patients they wrote, quote, when holding a cigarette, he put it to his mouth and smoked it if it was lit. And that is so interesting that stimulating this one region with a high intensity, high duration could cause somebody to take a cigarette, put it to his lip, and smoke it as if it was lit. So this is really interesting because typically stimulating the dorsal ACC only elicits really small movements rather than full-on goal-directed behaviors like smoking a cigarette. So it elicits these small movements, things like grasping or manipulating with the hands, touching one's face or body in a purposeful way, like rubbing your eyes or touching your nose or lips, changing one's posture, like maybe standing up from the bed that they're in, or looking around the room with the eyes or even the neck. And it's only when the stimulation intensity or duration is turned up, as in that 1973 study, that the movements turn into a full-on goal-directed behavior. So they interpret this as, okay, so if you just kind of prick it with an electrode and just deliver a low-intensity stimulation, it's only going to do like the beginning of this movement, right? But if you turn on the stimulation higher and for longer, it might cause somebody to do something like a full-on movement, grab this water bottle, unscrew it, take a drink even. But this sounds interesting, but what does this have to do with what the ACC, how it's organized? And because it seems like kind of a random assortment of movements, right? Touching the lips, touching the body, standing up, looking around. But Policia and colleagues note that the type of movement elicited depends on the particular area of the dorsal ACC that is stimulated. So interestingly, it seems that the dorsal ACC is organized along a sort of self to outside world gradient. Let's unpack that. What does that mean? So if you stimulate an area near the top of the dorsal ACC, the kind of superior regions, if you're familiar with that nomenclature, but near the top part of the dACC, this tends to cause patients to reach for their own face or body, right? Like rubbing the eyes, like we're talking about. If you move the electrode down a little and stimulate there, it tends to cause patients to reach out into the world, into what's called the peripersonal space. So grab the water bottle, right? If it's sitting on a table next to you. If you stimulate areas still further down, right, kind of near the bottom part of the dACC, it tends to cause patients to begin to actually move out into the world. That's that standing up out of bed, the changing the posture. If you move the electrode not down, right, but sort of forward a little, that's where you get those exploratory eye movements, causes patients to visually explore the room around them, moving their eyes or neck. And so I find that just fascinating, that stimulating different areas of this dACC seems to kind of move people from interacting with their own body, with themselves, with the space just around them, and then to stand up and move out of the world. I don't know. I just find that really interesting. But we've talked about so much about the ACC, about all these different functions, and I want to try to bring this together into a coherent picture, right? Like it just seems like there's so much that this one brain region is doing. So if we can kind of put it together, kind of summarize what we've already talked about, and then see what all these different functions have in common, maybe it will make the function of this region clearer. So to summarize, the ACC, the anterior cingulate cortex, is a crucial brain region that plays a central role in complex decision-making processes by calculating the value and uncertainty of potential outcomes. It integrates behaviorally relevant information across various timescales. It encodes high-dimensional information about future outcomes, and it's connected with regions involved in both emotion and cognitive control. The ACC's functioning in decision-making involves several key aspects. So first, value-based decisions, right? The ACC assesses the value of different options by calculating their potential risks and rewards. And this involves the prediction of future outcomes based on past experiences and recent observations. Different regions within the ACC represent aspects like average value and recent value, and they aid in the assessment of potential outcomes. So that's value-based decisions. It's also involved in checking progress toward goals, right? Looking into your berry pouch. Am I going to keep foraging for the day? The ACC is involved in monitoring progress toward goals and decisions about whether to continue pursuing a particular course of action. It helps determine when information needs to be sought to evaluate and adjust ongoing behavior. Next, risk and reward calculations. The ACC contains distinct sets of neurons that compute variables related to rewards and risks, including their magnitude and likelihood. These computations guide decisions by considering factors such as the potential for reward, the likelihood of success, the potential risks involved, and likelihood of those risks. Integrating, the next one is kind of integrating values. The ACC's rostral portion integrates the separate value calculations into an overall evaluation, which leads to a final decision. This comprehensive evaluation takes into account the magnitude and likelihood of both rewards and risks, associated with different options and kind of lands on that final decision. And then we talked about autonomic arousal and emotion. The ACC is not only involved in rational decision-making processes, but it also plays a role in autonomic arousal, right? Emotional experiences and interoception. It influences bodily feelings, changes in heart rate, blood pressure, and emotional states. And this connection between cognitive effort, autonomic arousal, and emotions is part of the ACC's role in decision making. It is regulating the body, regulating emotions in the context of decision making and behavior. Goal-directed actions. So stimulating different areas of the ACC, particularly the dorsal ACC, can elicit bodily movements aligned with goal-directed behaviors. The location of stimulation within the dorsal ACC corresponds to the type of movement generated. Right, we talked about the self-directed actions versus the interactions with the external environment. So let's pull all this together. The ACC serves as an integrative hub that combines value calculations, progress monitoring, risk-reward assessments, autonomic arousal, emotional experiences, and the execution of goal-directed actions. Its complex functions contribute to both rational decision-making and emotional experiences, demonstrating its significance in guiding human behavior and influencing overall well-being. So I was talking this morning with my co-host of the Social Brain podcast, Taylor Guthrie, about the ACC before I got on here. And him and I were agreeing that it seems to be this nexus between it seems to be this area that is just between kind of the super fine-grained rational analyzers in the cerebral neocortex, and then on the other hand, below it, these subcortical regions that are executing actions or changing autonomic physiology, or are even influencing the senses, the state of the body. And so it seems to be this integrative hub. It seems to be so involved in decision making and in so many different ways. It's monitoring progress, but it's also regulating autonomic arousal and emotional experiences. And so I think that perhaps a really good way of thinking about this is the ACC is maybe the central kind of decision-making area of the brain. That's maybe too simplistic. I think there could be other areas that are certainly involved in decision making, but it seems to be this hub where everything kind of comes together, and then an output of behavior happens after that. It triggering that output, not directly controlling it, not doing all the analysis and everything that's happening in the cortex, but being kind of this integration, this place where integration is happening. So I know that's a ton of information, and I'm going to kind of stop there. But it's, I think it's interesting to look at the brain piece by piece. And if you're interested in kind of other areas of the brain and what they do, check out my videos on the amygdala and the prefrontal cortex and the insula. That's the interoception video, but also the cerebellum. It's really cool to start to get a picture of what each kind of unit in the brain is doing, realizing that there's degeneracy in the brain. There are different populations of neurons, different areas can carry out the same function, but also that you can't perfectly divide the brain based on function alone. So that's a caveat there, but it still, I think, really helps to kind of zoom in on individual pieces of it and then put those pieces together, put the puzzle together and understand how the brain works generally. So anyway, make sure to like and subscribe to this video. If you are watching this afterward and you're not a patron of Sense of Mind, you can get access to these live streams, these monthly live streams, as well as the blog posts I mentioned. If you go to patreon.com/sense of mind, the link is in the description. Please check that out. Also, Taylor Guthrie and I, on the Social Brain podcast, we just launched a store where you can buy merch with super cool designs that you may have seen on some of the thumbnails of my videos and on our videos for the Social Brain. And that should be just below this video that you're watching. You should be able to just purchase kind of directly from YouTube. So definitely check that out. Every little bit counts. Every little bit helps. If you want to just do a one-time donation rather than signing up for the monthly Patreon or buying a product from our store, you can give this video a super thanks, which you should be able to find a little $ next to like the subscribe button somewhere in there. And you can hit that, donate however much you want. I really appreciate that. I love making these videos. I love doing this. This channel is a passion of mine, but it is costly, and I got to keep the lights on somehow. And it's now 100% independent. I no longer receive any outside funding. So you viewers and especially patrons make this happen. So thank you so much for watching. I'll catch you next time.